Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Welcome back to this channel. My name is Mufty Putratama Sumarto. I'm from Electrical Engineering on University of Indonesia. And now today's opportunity I was trying to spend to you about an introduction to wireless communication. So let's jump to it. Okay, first of all, I want to describe a little bit about our table of contents, what we are going to try to learn in this opportunity. Maybe for the first stop, we're going to discuss the timeline, the past, the present, and the future of wireless communication or network. And then the second one is a challenge that consumer or producer that faced in this technology. And then number three is regulation and standard that's set by governments or organization. Number five, I think it's related. I get to the most technology that currently used. So I will try to you about the development of cellular system and Wi-Fi, and then maybe some problems or definition or how it works in others. And then number six, we're trying to get more to the future, the wireless application that possibly can be applied in the future in many aspects. So, okay, let's jump to it. To the point number one, as before, is a timeline. First, the engine system. I think there's many systems that would make like smoke signal or carrier pigeons, but I think the most interesting one is the smoke signal that is used by the Americans. And then go to the radio system that is invented by Marconi in the 1880s. And then the radio itself were more developed during and after World War II. And then we get to the cellular system since 1988 approximately. And until now, it's 8 billion users. It is use voice data and multimedia. Yeah, it basically ignite the wireless revolution. It is used in third world countries growing rapidly. So after that, we also have Wi-Fi, also Bluetooth. It is also have a tremendous success and growth, and it's also widespread across the globe. And then we go to the future wireless network. I think it would be next gen cellular Wi-Fi, smart home or space, uh, smart cities, Internet of Things. There is currently in the development, I think. Internet of Things, it is on the horizon. I think it has an impact on many aspects of our life, like energy, retail, connect cars, cities, health, work, home, and etc. Next. So we're going to the challenge itself. They are divided into two. First one is network already challenge. The first one is must consider energy efficiency. Second one, the reliability and the coverage. The people in the rural area must have the opportunity to use network or radio, GPS data rates with no errors, or decreasing the errors values. Next is we must have a heterogeneous network and also seamless internet work hands-off. But on the device associated channel, the challenge were size, power, cost, energy, multi-radio integration, multiple antennas that is used, its performance, and hyperfrequency and wave. Okay, so next up, we're gonna discuss about the spectrum regulation and standard. Why we need them? Because it is currently there are many emerging systems. So regulation and standard must must be built. The spectrum regulation consists of its scarce public resource, hence it allocated some spectrum set aside for universal use and nation specifically. The example is spectral allocation in Indonesia is controlled by Kominfo, and other country make their own. Okay, next standard is interactive system require standardization, of course, because it's connect many people, so it have a standardization. And countries and companies want the system adopted as standard. Basically, the standard can be determined like IEE standard often adopted, and for worldwide, it usually determined by ITUT. Yeah, so these two is a regulation and standard for anticipate the emerging system. It has a new cellular software-defined system architecture, the system that have energy constraint and activity network, that have distributed control network, and its application of communication in many science aspects. So we need to. Okay, let's go to the cellular system. Basically, currently, we use for DLTE cellular. I mean, a majority, maybe in many countries or many cities, we still use for DLTE. The data rates is about 50 until 100 Mbps. In fact, we use up to 100 megahertz of spectrum. Have low packet latency, already have low packet latency and all network. Okay, so the idea is to change to or to upgrade the 4G into 5G. But well, first we want to know what 5G advantage are. First one, it have higher peak data rates. The second one, it has less radio latency. It has extreme mobile broadband and massive and critical machine communication. But I think that's not all. Maybe 5G can be upgraded into another more advanced technology, which to secondary spectrum is used in technology. Reach channel to maximize capacity, so it will have a GPS with feature, low latency, 99 coverage, and it have more efficient on the energy. Next on the Wi-Fi, I think there are by generation. LAN standard generation is divided by three: the old until 90s, the middle age, mid late 90s, and the current generation. So maybe the difference is a standard on the frequency band and the antennas and other bands is like packetization, antenna use, yeah, more multi user. So the speed. So basically, the more advanced, the more it have advantage. But Wi-Fi have a problem. There are 2 points that I want to show you. The first one is the Wi-Fi standard lack good mechanism to mitigate interference between that deployments. Second one, Wi-Fi system actually poor spectrum use and significant attention among APs and clients. So what I read is there are some solution to it. It is called self-organizing network for Wi-Fi. The definition is it is a dynamic self-organization network software to manage Wi-Fi APs. It is a low to capacity coverage interference mitigation trade-off. So it will provide network analytics and planning. So the solution could be the answer to the problem we have. And then I think it is the last part. It is the application that could be more advanced in the coming time, and it still in development steps. The first one is cognitive radio. It supports new users in existing crowd spectrum without degrading licensed users. It have multiple paradigm. And then the data collection and distributed controls. Basically, I think it's uh, large topic, but the topic that inside it is like I think is smart homes, buildings, smart structures, homeland security, event detection, battlefield surveillance, energy, and many other things that is could we control or could someone control in wireless uh, in the next uh, development. And then the next one is uh, an ad hoc network. It is peer-to-peer communication. The topology is dynamic. It's fully connected with different links, and it is open question. Next, chemical communication. It's technology in chemical. It can be developed for both macro and micro scale communication. Next up is wave, massive or massive MIMO communication. It have large non-monotonic path. Yeah. The antennas are small, so it's perfect for massive MIMO. Its non-horizontal design holds significant promise. And the last one is health, biomedicine, and neuroscience. Yeah, it can in neuroscience, it can make a nerve network, EEG, signal processing for deep brain stimulation, and then on the biomedicine, I think it's for EEG, ECOG, or epileptic seizure location, and then yeah, so it can work on many body areas like basically in our heart it's ECG like heart rate, and then motion sensor in our foot or our hand. It can track our oxygen too, and I think the most advanced one now is I think is the wireless is can be used as a recovery from a nerve damage. Okay, so that's all the presentation about introduction to wireless communication that I want to tell you guys about. I hope explanation in these videos could add your knowledge and is beneficial for you. And I'm sorry if my explanation is unclear and maybe have some wrongs in it. So thank you once again. Wassalamualaikum warahmatullahi wabarakatuh. I see you in the next videos.